Question 19 says, a falling sphere viscometer is a device used to determine the viscosity of a liquid. A sphere falls through a cylinder containing a liquid and the terminal velocity of the sphere is measured. State why the temperature of the liquid should not increase during the measurement. Whenever you come across temperature in Unit 1, always refer to viscosity. And we all know they have an inverse relationship. I didn't say inversely proportional, I just said inverse relationship, meaning as temperature increases, viscosity decreases. So the answer should be an increase in temperature would cause the viscosity to decrease. But B says, a scientist measured the terminal velocity of an aluminum sphere as it fell through the glycerol. Show that the weight of the sphere is about the value given. Density is also given, diameter is given, so I have to make weight the subject of the equation eventually in my calculation. And I always suggest my students that whenever you come across a question of 3 marks and above, it's not a good idea to look for the answer initially. Just start calculating with whatever information you have available, and this will guide you towards your answer. So I have density, I have sphere, so and for weight I need the equation W equals mg, and for density equation is m by v, and if I make m, it's rho into v. So weight equals rho vg. Where did this come from, everybody? Weight equals mg and m equals to rho v. So if I replace m with rho v, I get rho vg. Don't confuse this with the equation for upthrust. Well, it is the same equation for upthrust, but there is a major difference. In upthrust, the density is of the fluid, and in weight, density is of the solid object that you're dropping in that fluid. So weight equals to rho vg. I have the value of density of aluminium given here. 4 by 3 pi d by 2 cube gives me the volume rho v, and finally multiply it with g. So this gives me the weight of the aluminium sphere, and the value is 4.76 times 10 to the power minus 3. I have repeatedly said this over and over again. Whenever you see a show that question, the answer has to be given to at least 1 SF higher than the show that value. The show that value was in 2 SF, my answer has to be in 3 SF. Next part of the question says, the terminal velocity of the sphere was 4.05 times 10 to the power minus 2 meter per second. Deduce where Stokes' law applied to the falling sphere. Density of glycerol is given, viscosity of glycerol is also given. Always remember, when a question says whether Stokes' law was applicable or not, you have to compare it with the drag force. You have to compare it with drag force. And if the drag force is equal to the Stokes' law force, then and only then you can say Stokes' law is applied or obeyed. So when a question says whether Stokes' law is applicable, always remember you need to check whether the Stokes' law force is equal to the drag force. So what you have to do for this question is find these separately. First, find out the Stokes' law force, and you know the equation, everybody, for Stokes' law force is F equals 6 pi eta RV. You have all the values that you need for Stokes' law force, and then you find out the drag force and you compare them. And you have to give a conclusive statement. What is the statement? Since Stokes' law force is equal to the drag force, Stokes' law is obeyed. Next part states, state one condition that must be met for Stokes' law to apply. What are the conditions? For Stokes' law to be applicable, the speed of the object must be low, fluid flow around it must be laminar, or the object must be small and smooth. Part C says, a scientist used the viscometer to measure the viscosity of blood. The viscosity of blood is typically in the range 3 times 10 to the power minus 3 Pascal second to 4 times 10 to the power minus 3 Pascal second. Explain why the scientist should use an aluminium sphere with a much smaller diameter than the sphere used with glycerol. Do not include a calculation in your answer. The question specifically says you don't have to calculate anything, just construct your answer based on the information you have available. So, viscosity of the blood is much lower. How do I know this? Because you compare 3 times 10 to the power minus 3 or 4 times 10 to the power minus 3 with the viscosity of glycerol that's given in the question, 9 times 10 to the power minus 1. Minus 3 and minus 1. So minus 1 is much greater, 100 times greater than 10 to the power minus 3. So if the viscosity is lower, drag force will be lower for a given velocity. So reducing the diameter. So this is the question. So this part of the question says that this is what we have to ensure, that we have to use a sphere with much smaller diameter. So this will reduce the weight as well. So forces are balanced at a lower speed, meaning terminal velocity will be lower. This is what we want, everybody. We want the terminal velocity to be lower, because if it has a much higher terminal velocity, you know what? Let's go up for a bit. In this part of the question says, state one condition. The number one condition is speed of the object must be low. So I'm trying to ensure that the terminal velocity is kept as low as possible. Otherwise, the fluid flow around it will not be laminar, and that is a requirement for Stokes law to be obeyed.